Hi friend, when we start our robotic project, what we do is basically start with breadboards, as you can see here, and start making connection using a jumper wire or connecting wire, the single core copper wires. And it's very easy to make. That's one good thing about this, quick to assemble and disassemble. And then slowly we quickly move to breadboards, the Arduino boards, or any robotic projects related microcontrollers. Easier to make connections, connect the jumper wires on the top of the female header pins on the board, or it could be any type of pins. But the issue with this kind of connection is that uh, though they are easier to make it, but are they reliable? Easier to make, but most of the time what happens is they become loose. It's not really uh, that they work, but sometimes they work, sometimes they don't work. They rusted actually, they become loose. And the same thing happens even for microcontroller board. Though initially they look very tight, it's very sturdy, but they don't work. So what is the solution around that? Although there could be many type of solutions, one of the thing is to direct solder. But in my case, what I am doing is take the breadboards, a Vero board, that's the thing, real thing, and solder the male pin header along on the top of the breadboard, and then connect this directly to the microcontroller board. So that way they are very tight. It can be easily taken out and it can be connected. And then what we do is directly solder the pins, the wires from across the accessories on the Vero board. So that is easiest things to fix the problem. Although it may be possible that it may not work, but it's easier to fix the problem this way. So let's see how we can do it, how to proceed it actually. So this is my obstacle avoidance robot. Initially I started with a breadboard, breadboard, and then the connection was loose, so I replaced the breadboard to direct connection on the top of microcontroller. So now even that is loose. So what I'm doing is I'm cutting a small pieces from the breadboards, the copper breadboard. In fact, it's a Vero board. Uh, Putting on the top of Uno microcontroller, soldering the male header pin, and then going to connect, solder the different accessories from servos, from ultrasonic, from LCD screen, and and then the power sources, power inputs required for LCD screen display. So this is the way of proceeding. So this is soldering process you are watching. The only thing we need to take care is to make sure that while soldering they don't interconnect the pins. So for that what we have to do is to clean that solder leftover with a flux cleaner liquid, and then what we do is just to make sure that things are fine, we should take a sharp knife and clean the adjacent space between two pins. So that way make sure that nothing is getting soldered between two different pins. So the soldering part is done and the male header pins are connected to the Vero board. So as you will see that, so this is the connection part. So there are two sets, there are three sets in fact, from 8 to 13, from 0, 1 to 7, and the power part. So there are three part made it. And once this is done, So this is cleaning process here using flux cleaner liquid. So that way the soldering part looks clean and good. Once the cleaning part is done, I'm going to solder the different wires from servo motors, ultrasonic, the motor driver pins, wiring connections, the LCD wires here. So this is the soldering part for LCD power. And this is for LCD screen connection, and this is for ultrasonic sensor and servo motor. This part is for driving the motor. The four parts wires here that is connected to brush DC motor. So what I'm doing is using the knife, I'm cutting the space between two adjacent soldering area. So that way there is no short circuit. And now the powered on servo is moving and checking for the ultrasonic connection here. So this is a right connection, a right side distance. This is a left side distance. Thank you very much for watching this video. If you like it, please share it.